Assalamualaikum dan selamat pagi semua. Hari ini kita sambung dengan reaction mechanism untuk tindak balas yang kedua, iaitu reaction of alkenes with acidified water. Okey, kita mulakan dengan contoh yang pertama. So, let's say we have a propene react with acidified water, which is the water in the presence of strong acid, which is H3O+. So it will form a product of addition, of the hydrogen atom and the OH atoms. But remember, the addition must follow Markovnikov's, so the hydrogen atom will be added to the carbon double bond with a greater number of hydrogen. So now we have a product of alcohols, which is the secondary alcohol. Okay, so now how do we write the mechanism for this reaction? Okay, so let's start. Okay, so let's start with step number 1. So in this step, involve the protonation for the alkenes, which is the alkenes will gain 1 proton from the acid. So since the alkenes contains of carbon-carbon double bond, so the alkenes will be the nucleophilic site. So reacting with acid, which is the H3O+, so H3O+ will be the electrophile. So the carbon-carbon double bond, which is the nucleophilic site, it will attack one of the proton from the acid and breaks the bond between the hydrogen atom and the oxygen atom. And then it will form a product of addition of the hydrogen atom to the carbon-carbon double bond. But remember, the addition of the hydrogen atom must follow the Markovnikov rules. So which is the hydrogen atom is added to the carbon-carbon double bond with a greater number of hydrogen. So the adjacent carbon of carbon-carbon double bond will become carbocation. So now we have formed the secondary carbocation. Alright. Now, for the next step, since we have produced the carbocation, so now the carbocation is easily attacked by the nucleophile. So the only nucleophile that we have in this reaction is the water itself, which is water contains lone pairs. So it becomes the nucleophile. So now this nucleophile will be attacked by using its lone pairs to the carbocation, which is the electrophile, and then form a product which is called the protonated alcohol. So now we have this, which is carbocation form a new bonding with the H2O by using one of the lone pair from the oxygen atom and form the protonated alcohols. Okay, so now we have this product which is called the protonated alcohol. So this protonated alcohol, so we can see from the structure that is relatively unstable for the oxygen atom, which is having the positive charge. So the next step, we have to remove one of the hydrogen from the H2O plus in the protonated alcohol to make this structure become more stable. So now we proceed to step number 3, which is deprotonation. So from step number 2, we have produced the deprotonated alcohol, which is contains of H2O plus, which is the oxygen, is a positive charge. So this makes this protonated alcohol become the electrophile. So to remove one of the proton from this protonated alcohol, so we need a nucleophile. So the only nucleophile that we have in this reaction is water itself, which is water contains the lone pair. So they are rich of electron species. So they are using the lone pair from the oxygen atom to remove one of the hydrogen from the H2O plus by using its lone pair. So it breaks the bond between the oxygen atom and the hydrogen atom. Then it will produce a product of O, now bonded only to one hydrogen, and it gains one more lone pair. So now this alcohol becomes more stable when it has removed one of its proton, and the H2O plus is now become H3O plus, which is one of the lone pair has been used to bond it with the new hydrogen from the protonated alcohol. So now we have a stable alcohol, which is the secondary alcohol. Alright, so now to the next example. Okay, let's say we have the 2-methyl butene. So when 2-methyl butene react with acidified water, which is the water in the presence of the strong acid H3O plus, so the addition of the hydrogen will be added to the carbon double bond with a greater number of the hydrogen. So it will add it to this carbon. And then the OH will be added to the adjacent carbon of carbon-carbon double bond. So now we have this product. But now how to write this reaction mechanism? So we start with step number 1, which is involve the formation of carbocation. So we have this 2-methyl 2-butene reacting with acid catalyst, which is H3O plus, so in this reaction, so we can see that the alkenes contains of carbon-carbon double bond. So this carbon-carbon double bond is the rich electron region. So the carbon-carbon double bond will become the nucleophilic site. So it is very reactive to react with the electrophile, which is in this reaction, the electrophile is the acid catalyst. So the carbon-carbon double bond will attack one of the proton from the acid and breaks the bond between the hydrogen atom and the oxygen atom. From this reaction, it will produce a carbocation which is involve the addition of the hydrogen atom from the acid that must follow the Markovnikov rules. So the hydrogen will be added to this carbon-carbon double bond. The adjacent carbon of carbon-carbon double bond will become the carbocation. So now from this reaction, we have produced the tertiary carbocation. From step 1, we have produced the tertiary carbocation. So we proceed to the step number 2, which is the reaction of this carbocation with a nucleophile. So this tertiary carbocation is very reactive toward nucleophilic attack. So the only nucleophile that we have in this reaction is water itself. Water having two lone pairs, so we'll use one of the lone pair to form a new bonding with the C+, which is the electrophile. So it will produce a product of protonated alcohol. Which is oxygen atom using its lone pair to bond it to the carbon and having a positive charge. So now we have this product which is called the protonated alcohol. So this protonated alcohol is relatively unstable, which is we can see the oxygen atom, which is the electronegative atom, having a positive charge. So to make this structure or the oxygen become more stable, we have to proceed to the next step. So the next step is step 3 for deprotonation of this protonated alcohol. So from the structure of the protonated alcohol, we have a positive oxygen atom. So this protonated alcohol will become the electrophile. So it is very reactive toward nucleophilic attack, which is the only nucleophile that we have here is water itself. So the water will use one of its lone pair to get one of the proton in the H2O plus. So using the lone pair, it removes one of the proton from the H2O plus and breaks the bond between the oxygen atom and the hydrogen atom. So now it will produce a product of a stable alcohol. Which is the H2O plus has removed one of its proton and left only one hydrogen atom, but has gained one of its lone pair. Now it becomes a stable alcohol. So what happened to water here? So since water has gained one of the proton from the protonated alcohol, so water now becomes H3O plus. So what we have here is the stable tertiary alcohol which is the product formed according to the Markovnikov rules. So we call this product as a major product. Alright, so now let's try for another examples. So let's say we have an alkenes of 3-methyl and 1-butene. Alright, so if 3-methyl, 1-butene, react with acidified water, which is the H2O in the presence of H3O plus. So what is the major product form? Alright, so now how can we determine the major product for this reaction? So we can write the reaction mechanism accordingly to this reaction to determine the major product. So now let's start with step number 1. Step number 1 for this reaction is to show the formation of the carbocation. So since we have the 3-methyl and 1-butene, so the presence of carbon-carbon double bond here shows that this alkenes is a nucleophilic site. So it's very reactive toward electrophilic attack. So the electrophile that we have here is the acid catalyst, which is the H3O plus. So this carbon-carbon double bond, which is a nucleophilic site, will attack one of the proton from the H3O plus of acid catalyst and breaks the bond between the hydrogen atom and the oxygen atom. So what we have here is involve the addition of the hydrogen atom to the carbon-carbon double bond. So but we have to remember that the addition of the hydrogen atom to the carbon-carbon double bond must follow the Markovnikov rules. So the hydrogen atom will be added to this carbon. So the adjacent carbon-carbon double bond will become carbocation. So what we have here is only a secondary carbocation. So if we observe the structure that is forming a secondary carbocation, so it is also possible to form a more stable carbocation after the rearrangement. So we can see here that the neighboring carbon of the carbocation contains the hydrogen and the methyl groups. So it is possible to rearrange the position of one of these group of atoms to the carbocation to get a more stable carbocation. So that means we have an additional step for this reaction mechanism, that is to show the rearrangement to get a more stable carbocation. So the second step is to show the rearrangement of the carbocation. From step 1, we have produced the secondary carbocation. So as we can see that the neighboring carbon of the carbocation contains hydrogen and the methyl. So this is possible for 1,2 hydride shift, which is involved changing the position of the hydrogen atom from the neighboring carbon to the C+. So after the rearrangement, we will get a new stable carbocation, which is forming a tertiary carbocation. So by comparing the carbocation that formed from the first step and the second step, so we have formed the secondary carbocation and the tertiary carbocation. So we know that the tertiary carbocation is more stable than the secondary carbocation. So the next step, we will proceed for a mechanism that involves only a stable carbocation, which is the tertiary carbocation. So now we proceed to the next step of reaction, which is step number 3, that involves the nucleophilic attack to the carbocation. So we have produced this tertiary carbocation and attacked by the nucleophile. So the only nucleophile that we have here is only water. So water will use one of its lone pair and attack the C plus to form a new bonding to the carbon. The product form a protonated alcohol. So this is the new bonding using the lone pair with H2O, and the H2O is attached to the carbocation with positive charge. So now we have this, a product of protonated alcohol. Okay, so this protonated alcohol is relatively unstable due to the positive charge of the oxygen atom. So we have to remove one of these proton from the H2O plus in the protonated alcohol to make this alcohol become more stable. So then we have to proceed for the next step, which is step number 4, involve the deprotonation for the protonated alcohol. So we have here the protonated alcohol, which is oxygen having a positive charge with two hydrogen atoms. So to remove one of the proton from the protonated alcohol, so we need a nucleophile to remove the proton. So the only nucleophile that we have here is only water. So we use lone pair of the oxygen atom in water to remove the proton from the protonated alcohol and breaks the bond between the hydrogen and the oxygen atom. So it will produce a product of a stable alcohols which is the H2O plus in protonated alcohol is now only has one hydrogen atom and gain one of a lone pair. So what happened to H2O after gaining one of the proton from the protonated alcohol? So the H2O become H3O plus. So now we have a more stable alcohols as a major product that follows the Markovnikov and involve the rearrangement during the mechanism.